Okay, we're going to do a quick review of graphing a parabola without a table. So I've got a parabola quadratic written here. Its graph is the parabola. It's y equals x squared minus 3x minus 4. To graph a parabola, we need a couple of key pieces of information. The first is we need to find our x-intercept. Alright, the thing about all x-intercepts is that the y value equals 0. So if I take my equation, y equals x squared minus 3x minus 4, and I put that 0 in for y, I get this. 0 equals 3x squared, or x squared minus 3x minus 4. And now I can just factor that to find my x-intercepts. And the factors for this are x plus 1 and x minus 4. Using the zero product property, you set each factor equal to 0. And I get x equals negative 1 and x equals 4. So my first x-intercept is at negative 1, 0. My other x-intercept is at 4, 0. Now a parabola does not have to have two x-intercepts. It could have one or it could have none, depending upon where it's located. So I'm going to put a point at negative 1, 0 and at 4, 0. 1, 2, 3, and 4, 0. Okay, so there's my two x-intercepts. The next piece of information I want is my y-intercept. Now the y-intercept is actually really easy to find because the y-intercept, all x's are 0. So if I take my equation again, of y equals x squared minus 3x minus 4, and I put 0 into all my x's, I get y equals 0 squared minus 3 times 0 minus 4. Well, that's just negative 4. So my y-intercept is at 0, negative 4. Give this one a different color. And that's right here. Okay. Now you're probably saying, well, this doesn't look like much of a parabola. Well, it will be. We're missing the last key piece of information, and that is its vertex. Now to remember, a vertex of a parabola is the point at which that parabola changes direction. Some of you might think of it as the point that's exactly in the middle, and it is. It's either the lowest point of a parabola, the highest, or it could be even on the side, but it's the point where that parabola changes direction. It's also the point where the line of symmetry through our parabola goes. It's where, if we draw a line through a vertex, all our points of our parabola are going to match up, so we're going to have mirror images. So I know that my vertex is going to be exactly in the middle between two mirror points. And I already have two mirror points. And those are my x-intercepts, the negative 1 and the positive 4. So to find my vertex, and I'm actually going to go way over here on the side here. And the first step to find that vertex is to find that point exactly in the middle. So I'm going to take my first step of this is I'm going to take my two x-intercepts, and that's the negative 1 and the positive 4, and I'm going to add them together and divide by 2. That's going to give me the exact middle between them, and that is 3 over 2, or 1.5. So that tells me that my line of symmetry is, let me clean this up, right about here. Okay? So that's the middle part of my parabola. You don't normally have to draw the line of symmetry. I just do it there to help you see where everything is. Now the second part of finding my vertex is I've now got to put that x value back into my equation to find my y value. I probably should have given myself a little bit more room. So y equals 3 halves squared minus 3 times 3 halves. And why'd I write a 4 there? minus 4. Okay? Well, I'm going to bring my work down here a little bit. 3 over 2 squared becomes 9 over 4. Negative 3 times 3, because I'm going to multiply the negative 3 times the 3 halves, so it's negative 3 times 3 is negative 9 over 2 minus 4. Common denominator is going to be 4. So the 9 over 4 stays the same. The second one, 2 times 2 gives me 4, so I've got to multiply 9 times 2, and that's 18. The 4 denominator becomes 4, so the top becomes 16. Subtracting. Combining these, 9 minus 18 is negative 9, minus 16 is negative 25 over 4, or that would be about negative 6 1/4. So my vertex is at 3 halves, comma, negative 6 1/4. Now you're probably thinking, how do I know that 3 halves is at 1 1/2? Well, you can say, how many times does 2 go into 3, and that's 1, with a 1 remainder. Okay, so now let's plot that point, and let me give it a different color. Let's find a different, let's do green. Okay, so 1 1/2, I'm going to count down 6. 1, 2, 3, 4, 5, 6, and a little bit before, right down about here. So there's my vertex. I could see the left side of my parabola. So if I look here, here's the left side of my parabola. But my right side's kind of incomplete. So I can always add in what's called a mirror point. Now we have our two x-intercepts. There's mirror points here. But look at this y-intercept. It's on the left side of my line of symmetry, so there's got to be one in the exact same spot on the right side. And that's going to be right here. So that allows me to help get the second half of my parabola. Alright? So that's how you graph a parabola without a table. If you have questions, make sure you come and talk to one of your summer school instructors.